No dinosaur dominated the rivers like this apex predator. The Spinosaurus was perhaps the largest carnivorous dinosaur ever discovered. But recent discoveries challenge everything we knew about its lifestyle. For decades, it was portrayed as a land-based giant, much like others. However, fossils unearthed in North Africa told a radically different story. Its massive dorsal sail, once thought purely for display, served another purpose. The skull itself reveals a specialized, crocodile-like snout structure. These teeth were perfect for gripping slick, powerful aquatic prey, not shearing flesh. And now that we understand the head, let's explore the revolutionary body plan. Its hind limbs were surprisingly robust, suggesting terrestrial capability remained. Yet, evidence suggests its feet were broad, possibly paddle-like for propulsion. The body was long and serpentine, designed for efficient movement in currents. Crucially, fossilized internal structures indicate dense bone, lowering buoyancy. This adaptation allowed it to stay submerged, actively hunting beneath the surface. But this truly makes the Spinosaurus the first known giant semi-aquatic dinosaur. Its primary method of locomotion involved powerful strokes of its long tail. The tail fin was not rigid, it was a flexible, dynamic structure. This aquatic lifestyle dictated its diet, separating it from terrestrial hunters. Its main quarry were the massive, ancient fish populating these tropical waterways. The strike was sudden, utilizing momentum built underwater to secure the meal. The interlocking, conical teeth ensured no slippery catch could escape its grasp. It was the undisputed apex predator of this vast, water-dominated landscape. The but coexistence with land predators was inevitable in the coastal zones. When forced onto land, its sheer size often served as a sufficient deterrent. But now that we understand its aquatic prowess, let's consider its rivals in this niche. Other giant carnivores existed, but they specialized in different hunting grounds. But the Spinosaurus held the deep, moving water, others held the terrestrial fringes. A juvenile Spinosaurus likely spent more time on land, developing crucial terrestrial skills. But as they matured, increased sail size and limb structure favored aquatic life. Group dynamics remain speculative, but solitary hunting seems most probable for adults. And these ancient floodplains were hot, humid ecosystems, demanding specific physiological responses. The sail likely functioned as a massive solar panel for rapid heating or cooling. Hunting in murky water meant relying heavily on non-visual sensory input. Its structure may have allowed it to detect subtle vibrations made by swimming prey. The Spinosaurus patrolled massive territories within this sprawling river network. The fossil evidence confirms deposition in environments characterized by constant, strong water flow. It was perfectly adapted to navigate, not just swim, through these complex hydraulics. But the key to understanding lies in re-evaluating the tail's morphology from the latest finds. But older reconstructions depicted a stiff, heavy tail. The reality was far more flexible. But this powerful caudal fin meant incredible burst speed was achievable underwater. Arresting involved finding shallow sandbars or exposed muddy banks for leverage. The scale of its territory suggests a significant biomass was required to sustain it. At every feature, from the jaws to the tail, points toward a life deeply intertwined with flowing water. An even skin texture suggests adaptations for reducing drag while swimming long distances. The internal architecture likely contained air sacs to aid in rapid depth changes. By breathing remained a critical challenge, requiring frequent, but brief, surfacing. It utilized the element of surprise, lurking unseen in the turbid depths below. But this riverine world sustained a rich tapestry of large, specialized fauna. And even resting involved leveraging the water, perhaps partially floating to relieve weight. Its eyes, situated high on the skull, provided a critical view above the waterline. The sail's presence may have also acted as a visual signal in low-light conditions. When forced onto land, its gait was likely awkward, but still powerful when necessary. The transition back into the water, however, was always a return to its element. And the Spinosaurus ruled a world fundamentally different from any other large dinosaur. New discoveries continually refine this complex picture of adaptation and specialization. Our perception of this giant has evolved dramatically over the past few decades. It represents a unique evolutionary path, maximizing resources in a water-rich environment. Its sheer size combined with aquatic agility made it virtually unchallenged. But the secrets of the giant river monster are slowly emerging from the ancient sediments. But the Spinosaurus remains a powerful testament to nature's boundless capacity for adaptation.